Hello friends, my topic is gas power cycle. So before we start power cycle, in this power cycle, working fluid we use as a gas, and the engine working on these cycles may be cyclic or non-cyclic. In gas power cycle, we study different types of cycles: Carnot cycle, Stirling cycle, erection cycles. Okay, and when we come to the IC engines, then we will study in IC engines Otto cycle, diesel cycle, and dual cycle. When we comes out to be in power plant, we will study about the Brayton cycle. So the basic of these cycles are the working fluid. If the working fluid is gas, then these cycles are known as a gas power cycles. So the first one was Carnot cycle. Before we start Carnot cycle, I will tell you a story about the Carnot. How this Carnot cycle will be developed. In 1815, Napoleon War ended. A Napoleon War fought between England and France. Mr. Sadi Carnot, he is also known as the father of thermodynamics. Mr. Sadi Carnot was a military engineer in German military. After completing the war, when he lost the war, he thought, why we lost the war? The idea came his mind that we are not utilizing the proper energy concept. So that's why he started some investigation. In 1824, he developed a cycle. Now we know that cycle as a Carnot cycle. Okay, so what Carnot did? First we will draw the PV and TS diagram, then I will explain. The first question comes in our mind that when we are drawing these curves, why these lines are curvilinear? Why we are not draw these lines as a straight lines? So, as we know, there's the working fluid in the cycle used as a gas, and this gas is considered as an ideal gas, and we all know that ideal gas equation is PV is equal to mRT. So what Sadi Carnot thought, the two processes in Sadi Carnot is a isothermal process and two is a isentropic process. So what is isothermal process? In isothermal process, when we are talking about isothermal, iso means same, thermal means temperature. If the temperature is same, then these processes are known as isothermal process. And second one was isentropic process. Isentropic process. What is this isentropic process? Isentropic process is a reversible adiabatic process. What is reversible process? Now we are talking about reversible process. And before we going to reversible process, what is process? So let's tell you what is process. Process is nothing but a change of state. Suppose at t equal to 0, the state of any object is A. If we change the state, so this is A to B. It is a process. So process is a change of state. Now we come to the reversible process. What is the reversible process? If we go 1 to 2, A to B, and then we come back to B to A without leaving any effect on the system or surrounding. These processes known as reversible process. So now comes to the isentropic process. What is isentropic process? Reversible adiabatic process. So now comes to the adiabatic process. What is adiabatic process? When the energy cannot be added to the system or leave to the system, so then this system is known as adiabatic process. So okay, so in Carnot cycle there are two processes. Two processes were isothermal process and two were isentropic process. Now came back to the same point, why these lines are curvilinear. This equation is ideal gas equation. This is called PV is equal to MRT, and this temperature is constant. So now we can say PV is equal to constant and PV is equal to C by V. So this is shown that Y is equal to 1 by X. In mathematics, we studies the graph of Y is equal to 1 by X in certain manner. So that's why I am drawing this equation in certain fashion. Okay. So this is how we can draw this PV diagram. Now comes to the TS diagram. Process 1 से 2. Process 1 to 2 is isentropic compression process. Isentropic compression process. Process 2 to 3 is isothermal heat addition. Process 3 to 4 is isentropic expansion process. Process 4 to 1 is isothermal heat rejection. So 1 to 2 is a isentropic compression. Isentropic compression. Isentropic means entropy is a constant. So this is 1 to 2. Then isothermal 2 to 3. Then 3 to 4. The one questions came into our mind that why these cycles are in a clockwise direction. Why we are drawing arrows in this direction, not in a reverse direction? Because these cycles are power producing devices. That's why we are drawing the cycle in a clockwise fashion. Now the important task is we will analyze the each and every process. The process 1 to 2 is the isentropic process. Process 1 to 2, isentropic compression process. That means Q 1 to 2 will be 0. This is isentropic compression. Isentropic. This is isothermal. Same isothermal. Isentropic expansion, isentropic compression, isothermal heat addition, and isothermal heat rejection. So now Q1 to 2, isothermal compression process, then energy will be 0. No heat will be transferred because it is a reversible adiabatic process. So from 1 to 2 it will be a 0. Now W1 to 2. W1 to 2. That is P1 V1 minus P2 V2 divided by gamma minus 1. As we all know from the ideal gas equation, PV is equal to mRT. So we will write here M, if we are considering that for a unit mass, that RT1 minus RT2 divided by gamma minus 1. So we will write here R over gamma minus 1. This is T1 minus T2. So we can write here R over gamma minus 1. We can write it R over gamma minus 1 is CV, T1 minus T2. Now goes to the process number 2 to 3. What is process 2 to 3 is a isothermal heat addition. From ideal gas equation, we will know that Q2 to 3 is equal to W2 to 3 is equal to RT2 log V3 by V2. Now, if we give this equation number 1, equation number 2, now comes to the process number. I love this. Process 3 to 4. What was that? Isentropic expansion process. So similarly, Q3 to 4 will be 0 and W3 to 4 is equal to P3V3 minus P4V4 divided over gamma minus 1. If we will solve it, we will receive CV T3 minus T4. This is equation number 4. Sorry, equation number 3. Now comes to the process 4 to 1. It is also a isothermal heat rejection process. So Q4 to 1 is equal to Q W4 to 1, that is equal to RT1 log V4 by P1. So this is equation number 4. So as we all know, we have to find out the efficiency of the Carnot cycle. And what is efficiency? Efficiency is the output upon input. What is output? What we want? Work done from the system, and then input, the heat supplied to the system. So this is W net divided by heat supplied to the system. If we talk about in a cyclic process, because this is a cyclic process, if a source sink diagram consider, this is source and this is sink and this is your heat engine, then what will be the work? If it is a Q supply, this is a Q rejected, then W net will be QS minus QR. So this is heat supplied minus heat rejected divided by heat supplied. So the efficiency comes out to be 1 minus heat rejected divided by heat supplied. From equation number 4, we have heat rejected, and from equation number 2, we have heat supplied. So now put this value in our equation. One minus heat rejected, that is RT1 log V4 by V1 divided by R T2 log V3 by P2. So if we simplify this equation, 1 minus efficiency is equal to 1 minus T1 log V4 by V1 divided by T2 log V3 by V2. Process 1 से 2 is isentropic compression process, and we all know that for isotropic compression process PV की power gamma is equal to constant. We are using this equation. If we relate this equation 1 से 2, then P1 V1 की power gamma is equal to P2 V2 की power gamma. Then we will find out P1 by P2 is equal to V2 by V1 की power gamma. Now, if we are dealing with PV is equal to MRT, then P1 V1 by T1 is equal to P2 V2 by T2. So, if we relate this equation 1 and 2 in terms of temperature, then it will comes out to be V1 by V2 is equal to T2 by T1 की power 1 divided by 1 minus gamma. Now V1 by V2 is equal to T2 by T1 की power T1 की power 1 by 1 minus gamma. If we put this equation in P2 by P1, then we will receive this equation. Similarly, 1 से 2 is a 3 to 4 process. Then what we will get? V3 by V4 is equal to T4 by T1 की power 1 divided by 1 by gamma. If now we will solve this equation, then T2 by T1 is equal to V1 by V2 की power 1 minus gamma, and then T4 by 3 to 4 3 T4 by T3 is equal to V2 by V3 by V4 की power 1 minus gamma. And from this equation we can see that T2 is equal to T3 and T1 is equal to T4. From this equation we will solve, then these equations will cancel out. Then what we receive? Efficiency is equal to 1 minus T1 by T2, and this is called as the efficiency of the Carnot cycle. My dear friends, will not confuse that in most of the book we will study about the efficiency as 1 minus T2 by T1. So never confuse with T1 or T2. It is a lower temperature divided by higher temperature. From our TS diagram we will see that our 1 is a lower temperature and T2 is a higher temperature, because it depends on the cycles from which point you are starting the cycles. Some of the books you will study about from 1 to 2, it is a isothermal heat addition, then expansion, then rejection, then compression. I am starting this from the compression, so that's why you will receive this equation as 1 minus T1 by T2, not T2 by T1. So from this equation the Carnot conclude that the efficiency of the engine will only depends upon the temperature limit, not only the working fluid and not on the pressure, not on the volume. It only depends upon the temperature, source temperature and the sink temperature. But this cycle is practically not possible. Why this cycle is practically not possible? Because in Carnot cycle there are two processes. One is the isothermal process and next is the isentropic expansion process. So one is the isothermal, means temperature is constant, and temperature isothermal is a very slow process. Take your palm and slowly you will rub it, then you will feel the temperature of this palm will not increase. That means this is the isothermal process. And next is the isentropic process. That means the reversible adiabatic process. The heat cannot be transferred from the system or added to the system. So that's why it is a very fast process. So one is a very fast process, another is a very slow process. So that's why this cycle is practically not be possible. So the question comes into our mind, why we are studying this cycle? This cycle we are studying for the comparison. Using this cycle we will compare the other cycles. So efficiency of this cycle is 100%, or you can say that no such device have more efficiency than the Carnot cycle. Okay, thank you. In next lecture we will discuss about the next cycle.